This is the second update to my study of the world record distance landscape photography photo. The first update applied the 443-kilometer distance to the arc of the circle rather than the chord of the circle to result in a 52/1000th of 1% increase in accuracy of the calculation. With this update, we will calculate the exact blocking elevation. Again, this graph is the elevation of the bulge above the peak of Mount Fenestrelle and the elevation of Mount Gaspar above the peak of Mount Fenestrelle. Mount Fenestrelle is simply subtracted from itself to yield 0. This calculation is actually very simple. The line of sight between the peak of Mount Fenestrelle and Mount Gaspar is a slope, so the elevation of the line at its midpoint is simply the elevation of Mount Gaspar divided by 2. 1057 divided by 2 equals 528.5 meters. Subtracting this product from the elevation of the bulge yields the total blocking elevation. 1074 minus 528.5 equals 545.5 meters. Total blocking elevation. I would also like to note that my original final calculation in the white letters on the left side of the graph show that my original estimate of greater than 538 meters was actually very conservative. The actual blocked elevation is 7.5 meters higher than my original estimate. One last thought. Mount Gaspar is situated beyond a lot of elevated terrain. We shouldn't expect the photo to look like a single mountain at the end of a pool table-like surface. We shouldn't expect to see the entire mountain from peak to sea level. And as always, laws of perspective apply. I recommend the P-Brain channel for excellent, helpful studies on perspective. What follows is the first update in the original video and the perspective study by P-Brain. Thank you for watching. Based on a posted comment, I wanted to revisit my study of the world's record distant landscape photography between the two mountains in France. The mountains were 443 kilometers or 275 miles apart, and I calculated the globe bulge between them. Here is the comment. It reads, "But AB is wrong. Shown is through Earth, but measurement goes over surface of Earth. AB through Earth is shown too far apart. AB over surface of Earth would appear closer together." This simple, obvious, huge error that anyone can hear in the first sentence instantly discredits this entire video. Concerning the second part of the comment, these graphs are not to scale. That should be obvious to most viewers. The purpose of the graphs is to illustrate the math. Now let's look at the first point. This is something I considered when I first made the video. Yes, the 443 kilometers should go over the surface of the globe and not through the Earth. My thought was that it could not make that much difference to the outcome, and noted that the Metabunk calculator used the same method, and our results were basically the same. But in the interest of answering the commenter, and finding out how much difference it really makes, we will do the additional calculations. What the commenter is saying is that the 443-kilometer distance between the mountains is over the arc of the circle and not through the chord of the circle. This I agree. Now let's see how much of a difference it makes, and if it was an obvious huge error that instantly discredited the entire video as claimed. First, we must calculate the angle A. And please note, this graph is not to scale, but is to illustrate the math and the method. A equals 360 times L, which is the length of the arc, divided by 2 pi r, which is the radius of the globe Earth. The answer is A equals 3.984 degrees. Next, we calculate the chord. C equals 2 times r, the radius of the globe, times the sine of the angle A divided by 2. The answer is C equals 442.91 kilometers, and this would be versus the 443 kilometers that I used in the original calculations. This number is less than 1/10 of a kilometer difference. Next, we'll calculate the bulge using the method used in the original video. H equals 3,850 meters versus the 3,852 meters in the original calculation. This is a 2-meter error, or 52 thousandths of 1% error. This is a screenshot of the original calculation, and at the bottom I'm showing the corrected number. This is a screenshot of the total globe bulge, which includes the terrain, elevation, and we can see again it's a 2-meter difference. Here's a graph of the elevation of the two peaks and the bulge, and I show the correction in green. This is a screenshot of the graph where I subtract the elevation of Peak Fenestrelle minus itself and the bulge and Peak Gaspar. The correction is in red for the bulge. Here is the correction for the blocking elevation, and the answer is greater than 537 meters versus the original calculation of greater than 538 meters. The difference is 1 meter, or about 3 feet. So, having done the math, we can assess the validity of the commenter's assertions. What follows is the original video, and after that, a classic study on perspective by P-Brain. Thank you for watching. This is a study of the current world record of distant landscape photography. It's taken in France from Peak Fenestrelle to Peak Gaspar. Total distance 443 kilometers. And here is the picture. Here is my screenshot of Google Maps showing the two mountains and the distance. This is a detail of Peak Fenestrelle, and its elevation is 2,826 meters, and I'm using the Wikipedia data throughout. Here is a detail of Peak Gaspar, and its elevation is 3,883 meters. This is a detail of the town that's right in the middle between the two mountains. This would be 221.5 kilometers from each mountain. Its elevation is 50 meters average per wiki. Now let's calculate the bulge height between the two mountains on the fictional globe Earth. AB is the distance between the two mountains, 443 kilometers. AD is half the distance, 221.5 kilometers, and DB is the same, half the distance, 221.5 kilometers. CE is the radius of the Earth in kilometers, 6,371 kilometers, and CB is the radius of the globe Earth. CD is our unknown. Using the Pythagorean theorem, we calculate the distance of CD, which comes out to 6,367.148 kilometers. The expected globe bulge is 3,852 meters. To the calculated globe bulge, we add the elevation in the middle between the two mountains, which is 50 meters. The total is 3,902 meters. Total fictional globe bulge. Here we see three red lines representing both of the mountains and the bulge in the middle. We see the total bulge in the middle is actually slightly taller than Mount Gaspard. The bulge in the middle is actually slightly higher, but I have made both the line for the middle and Mount Gaspard the same height. This actually favors the globe. The line representing Mount Fenestrelle is 73% of the height of Mount Gaspard. I've shown a ruler where 1 represents the height of Mount Gaspard. The height of Mount Fenestrelle is actually 73% of the height of Mount Gaspard. I have placed the line at 75% of the height of Mount Gaspard. This favors the globe model. Now we add the line connecting the peaks of Mount Fenestrelle and Mount Gaspard. As you can see, the expected globe bulge in the middle of the two mountains blocks the line of sight between the two peaks of the mountains. And as you can see in the actual picture, you can see much more than just the peak of Mount Gaspard. As we close this study, let us determine by how much the line of sight, mountain peak to mountain peak, should have been blocked according to the globe Earth model. This is a graph with the height of the lower peak, Mount Fenestrelle, subtracted from the height of Mount Gaspard and from the height of the globe bulge. Fenestrelle minus itself is 0. The bulge minus Fenestrelle is 1,076 meters. And Mount Gaspard minus Fenestrelle is 1,057 meters. We will now add the line connecting the peak of Fenestrelle with the peak of Gaspard. Because Gaspard is slightly lower than the bulge, the line intersecting the bulge height is at slightly lower than half of its height. So the amount of blockage is greater than 1,076 meters divided by 2. That is greater than 538 meters. In English units, this is greater than 1,765 feet of blockage according to the globe Earth model. Again, we see much more than just the peak of Gaspard in the picture. Before I close, let's check my results with the Metabunk calculator. Metabunk has the bulge at 3,851.6 meters. My calculation was 3,852 meters. But I notice one oversight at the Metabunk calculator. The Metabunk calculator has no place for terrain elevation, which is required to calculate the total globe bulge. I'm sure that's an honest oversight. Going by the globe drop calculator, the drop would be 15,420 meters. The hidden portion, which is based on the elevation of the observer, which in our case was Peak Fenestrelle, the hidden portion should be 5,030 meters. Peak Gaspar is 3,883 meters. That means it should be buried by 1,147 meters, or 3,763 feet. Now, if we look at their so-called standard refraction calculator, the hidden portion should be 3,810 meters. Peak Gaspar is 3,883 meters, which means that just 73 meters should be visible. That would be just 1.88% of the elevation of the mountain. If I were to grant that we are viewing the top 73 meters of Peak Gaspar in these pictures, and the cause of that is refraction, then let's go back to our prior graph and get a visual representation of what would be happening with refraction. Remember, the bulge is higher than Mount Gaspar, and we aren't just seeing the peak of the mountain. We are seeing 73 meters down the peak. So the light has to travel up and over the bulge and then back down to the observer at Peak Fenestrelle. And the light arrives to the observer in a coherent, recognizable fashion. This reminds me of a game we would play when we were kids, where we would throw a ball over the roof of the house. We can confidently determine by the current world record of distant landscape photography that the Earth is flat. I am Rick Zimmerman of Seventh Day Truth Seeker. Thank you for watching.
The Earth. Is it really just a big ball floating in space? Spinning on its axis at 1,000 miles per hour? Hurtling around the sun at 67,000 miles per hour? Whizzing through the Milky Way at a milk-curdling speed of over 500,000 miles per hour? And warp driving through the heaven at over 500 million miles per hour? And what about the sun? Is it really 93 million miles away and close to 1 million miles in diameter with a circumference of nearly 3 million miles? And it's constantly illuminating half of our entire Earth's surface with the rotation of the Earth, creating our 24-hour days, our night and days? Or, shh, the Earth is flat. And maybe it's completely still, just like we experience. And maybe the sun isn't big, but is very small and very close, and not illuminating the Earth from 93 million miles, but is illuminating locally. And maybe everything, the sun, moon, and stars, are not far away, but are circling overhead relatively close. In this video, we're going to explore the latter option, and at the end, we're going to reveal startling evidence through the use of time-lapse photography that the sun cannot possibly be 93 million miles away, but is in fact very close, and is illuminating locally as it traverses our flat Earth. Oh man, and watch how this sun comes at you. Boom! I mean, come on. And that's all perspective. If you look at jet trails, Google Images, you'll see them. They start out low at the horizon, they come up overhead. Look at that thing. They come up overhead and then they go down to the horizon. Perfectly explains what the sun would do. Here it is going overhead. I love time lapse. And look at this. You can't go out and look at the sun. You can't see this stuff, except that it's on, time lapse like this. It's incredible. Now watch this thing. It's sweeping. The sun over flat Earth is doing a big circle, right? Look at this thing. See it sweeping to the right? It's like a lefty bowler. Just toss that down the alley, and there it goes, hooking into the pocket. See how the clouds angle down to the horizon. I shot it there. That's exactly how the sun would do on flat Earth. Okay, back to the Copernican principle, and this is what they tell us. The sun is 93 million miles away. Now, I'm going to show you evidence through sunsets that shows the sun light following the sun over the horizon, and it shrinks as it goes over. Now there's no way it would do that if the sun is 93 million miles away. Okay, first I'm going to show you some footage from the ISS. Okay, now watch this animation. Watch this sunset. Now this is exactly, if they came to me and said do an animation, this is how I would do it. If the sun were 93 million miles away. Just like that. Have the whole horizon fade evenly. But that's not what we see. Okay, wow, look at that. Look how the light lifts off the ground like a big wedge, or like lifting up a sheet of paper. That's incredible footage. Definitely the light's following the sun, right? Okay, next I'm going to show you how a sun that is circling over the Earth, that creates the horizontal aspect of the sun. If you combine that with perspective, which creates the up and down of the sun, the rising and the setting, you get the 23.5 degree tilt that they talk about. It's nothing but perspective and the circling sun. Here's another sun sweeping out a big circle. Okay, here's a phenomenon that you might be wondering, how in the heck do you explain this on a flat Earth? Well, this footage is taken from Alaska during the summer, and the sun does look like it's going up and down. The reason it's doing that is that this town in Alaska is not in the center of the sun's circular circuit. In other words, the sun is making a big circle, and the town is not in the center of that circle. So the sun will be closer and further from the viewer with the camera. That will cause it to go higher and lower, and also maybe even bigger and smaller. Look at the high altitude airplane. Remember, this is from a high altitude balloon, so that airplane is probably at cruising altitude. Notice how it looks like it's going up from the horizon. That's exactly how the sun will rise, because that plane is staying parallel to the ground. And now watch, it'll go down to the other horizon. All right, again, perspective, that's how the sun will set. And forget the big ball, that's just due to a GoPro camera. But see how the sun, that's the point of this. And then also, look at the size of the sun, man. Look at that thing. I mean, there's something to it to say that we're higher up our view and the sun looks bigger, and it looks like it's not as high in the sky as it does when we're on the ground. Something to that. Let's explore this notion a bit further, that the sun looks bigger when filmed from higher up. The next 3 slides, I'm going to do a comparison, a side by side. The one on the left, the camera is above the clouds. The camera on the right is ground level. And the point for the side by side comparison from the ground level and the level above the clouds is that above the clouds we're only maybe a mile or so up. And if the sun appears to be closer to the camera, well, that means it's probably much closer, because if the sun were 93 million miles away, a mile closer wouldn't make any difference at all to its visual appearance. Okay, here's a little illustrator or a little cartoon from a website called timeanddate.com. It's really funny that they would have a perfect illustration of a sun rising and setting on a flat earth due to perspective. You'll notice that it rises from below the horizon and sets below the horizon. Now you might be saying, well, how's that possible? I can see now you're saying that it rises and lowers due to perspective, but how does it disappear below the horizon? Well, I got a theory about that. Because of the fact that all parallel lines and planes converge at your eye level horizon, this is according to the perspective, I'm not making this up. If in fact, and they do, they converge at your eye level horizon visually, then it makes sense that after that point they diverge, meaning they then separate. So the sun would continue on a downward track. As you can see from my illustration here, the lines would go to your horizon, and then afterwards they would spread out and separate, kind of like a starburst, and the starburst being at your horizon, at your focal point. Anyway, without further ado, we're going to start talking about, and I'm going to start showing you the time lapse of the sunsets that I'm talking about that clearly show the sun is close and illuminating locally. Here we go. Alright, and here are a couple of time-lapse sunsets, and just like the sunrises at the beginning of this video where you could see the sun coming at you, not maintaining any 93 million mile distance, here you can also see the sun moving away, and it's clearly not due to the rotation of the Earth and a sun that's maintaining 93 million miles away, but the sun is moving over the Earth and moving away from you. Okay, these next three slides, the sun is almost set already behind the horizon, but watch as the sunlight shrinks and follows the sun. It's definitely a locally illuminating sun, not far away, not very big, and definitely not 93 million miles away. Okay, remember this video from the beginning of the video? I showed you this one and how it's circling over the Earth, and watch it sweep to the right like a bowler bowling it in there for a strike. Okay, now I want you to pay attention to the way the light follows the sun. The sunlight's going to shrink, right, as it follows the locally illuminating sun. Now watch this. See it shrinking, following the sun? You do not get that if the sun is 93 million miles away. The entire horizon should fade evenly. Just like this supposed shot taken from space of the Earth. You can clearly see the way they depict it. They depict the demarcation between day and night, or light and dark, as a long straight line. And you can see the long straight line moving as one solid piece. That means that the sunset should all fade, the entire horizon should fade evenly. But that's not what we observe, as we will see and as we've seen in the footage so far. The sunlight shrinks and follows the sun over the horizon. So these time-lapse sunsets are definitely the nail in the coffin for heliocentrism. But this particular one here, shot from above the clouds from this observatory, is the final nail in the coffin. Look at how the sun just shrinks and the light shrinks to nothing. That cannot happen, as I showed you in the when the sun illuminates the entire Earth, which it does from 93 million miles away. It has to. You don't get this isolated look at the sunlight trailing the sun. That's only possible with a small sun, close, not very high, illuminating locally. I mean, if this isn't proof to you, then you gotta take the blinders off. Okay, and finally I want to show you some examples of local illumination, or a city in the background. This is from Grand Canyon National Park. You can see Las Vegas is one of them. You can see the stars going down, so you know that's not the sun. That's the glow of Las Vegas, it says. You can see that's local illumination. I'm just making an example showing you here's Tuba City and a little bit of Flagstaff. Now, in this one here, you see two lights. Obviously, we don't have two suns, but these are two cities lit up, and it's just to show it looks just like the sun going over the horizon. That's the point of me showing that. That's local illumination at work. The sun is not 93 million miles away, because if it was, the entire horizon would fade evenly, and the entire horizon would fade at the same time. Not what we see here, which is the small sun cruising over the earth and the light is following it. Case closed.